Hi there. Thank you for clicking on this video. In this video, we're going to start a deeper dive into the concepts of domain and range, and we're going to place the emphasis on quadratic functions as a starting point. But as we do so, I want you to keep in mind that domain and range are broader concepts than just how they apply to quadratics. So we want to focus on the definitions of domain and range and the underlying concepts, not so much in how they play out with quadratics. And because we want this knowledge to carry outside of quadratics into other types of function families, I'll try to call your attention to that as we go through the lesson. Please give this video a thumbs up if you find it helpful, if it answers some questions for you. Subscribe to the channel for more math content and check out the other videos we have, including the practice set on this topic. Domain and range can cause issues for students, so this is definitely one that you want to pay attention to. Make sure you're doing the practice problems and not shortchanging yourself. So for background information, this discussion of domain and range will make more sense to you if you check out my video on relations to functions, and you can find that in the Algebra 1 playlist. I might also have put it in the Algebra 2 playlist, but it will give you a bit of grounding in the vocabulary and like what we're doing when we're dealing with functions. So I'll put a link to that up here, okay, for you to click on if you would like to get that background information. I think it would be helpful for you. Okay, so a function is essentially a mapping from one set onto another, and it's a mapping that meets a particular requirement, meaning that every x maps to only one y value. And that's where that video up there would come in handy. We really look at these mappings and how functions are a specific type of mapping. Now, the set where the mapping starts is the domain. So essentially, you've got a set of numbers, okay, and we call that the domain, and there's a bunch of numbers, okay, in that set. And the set where the mapping lands is the range. So we have this other set of numbers, and we call that set the range. And what a function does is it takes numbers from that first set and maps them onto numbers in the second set. And again, go back and check that video out. It really breaks it down for you. Okay, and so that's what we're dealing with. We have these two sets of numbers. Now, the notation that we use to indicate that we're working with functions is this notation here, which is called f of x. And what that means is that this output, okay, whatever that output is a function of x. And that's literally what that means. F of x is just shorthand for saying function of x. X is the input, and we indicate the input by putting it in the parentheses there, meaning this is the set of numbers that we're plugging in, and your y value is your set of outputs. So sometimes you might see this, f of x is equal to y, simply indicating that x is your input, meaning it's in that first set of numbers, and y is your output, meaning it is in the second set of numbers. So that gives us a little bit of a background information, and it does help if you know a little bit about sets there. Now, in defining domain, this is what we want to focus on more than what is the domain of a quadratic, because what is the domain of a quadratic actually has a very easy, straightforward definition, which some of you will memorize, but it won't work outside of quadratics So first of all, the domain is the set of all numbers that can be used as inputs to a function. So it's this group of numbers that we have. So we have this group of numbers, and it's all the things, all the numbers. So 1, 2, 1.5, negative 3 halves. Okay. It's a set of numbers that you can plug into a function. Now, if that sounds overwhelming, this might clear it up, maybe. Often expressed in terms of what we can't choose instead of what we can choose. And the reason for that is that most of the time we can choose an infinite number of things. So you figure that number line has an infinite number of numbers on it, and we can pick an infinite number, but sometimes what we can't pick is actually a very small range. I don't want to use range there, but small set of numbers. It might be one number or two numbers, or it's like a region or interval of numbers that we can exclude. So sometimes when we're talking about domain, we just kind of say, well, I'm going to start with everything. Now that I have my set of everything, is there something I can't pick? Like maybe I can't pick a 3. Now here's an example. So we're going to work with, this is our like working example for the lesson. F of x is equal to 2x squared plus 8x plus 4. The domain consists of all the numbers that we can plug in for x. So if you picture your number line, okay, and your number line has positive numbers, negative numbers, it's got fractions, it's got like square roots or your irrational numbers. Is there anything on that number line that you wouldn't be able to plug in for x? So could I say f of 1 and plug in a 1? Sure. Could I say f of 0 and plug in a 0? Yep. Pick a negative number. What about f of negative 2? Can I plug? Yep, I can plug in a negative 2. Can I plug in a fraction? I don't want to, but I can. Okay, I can plug in a fraction. Can I plug in a square root? Yep. I'm not going to really want to do that either, but I could plug in a square root and I could evaluate that and get some number. So in the case of quadratics, we can actually plug in anything. So you can go as far left or as far right. You can go in between the numbers. You can find all the ugly numbers. If it's on that number line, you can go ahead and put it in there, okay, and get some number out. Now, there's no guarantee it's got to be a nice number. It might be an ugly number with fractions or square roots in it, all kinds of stuff. But you could get a number out. So you're not going to end up with something that's impossible. Now, if you're wondering, well, what would be impossible? Well, impossible could be something like dividing by a 0. Okay, and because there's no division here, we don't need to worry about that happening. But in a quadratic, you can plug in anything. So how do we express that when it comes to quadratics? How do we express the I can plug in anything? So right here, I want you to picture your number line. Okay, and at the center of the number line is 0. You've got your positives and your negatives. Going out to the positive side, it goes all the way out to positive infinity. And I am aware that infinity is supposed to do that. But if I keep doing that, it starts to look really bad. So I gotta make my infinities look like that. I am aware that most students think that that's janky. Just roll with it. Okay, so that goes all the way out to infinity. Okay, going in the other direction, we have this idea of negative infinity. So we can just keep going further and further and further to the left. And so we're going from this positive infinity to negative infinity. So the domain for all quadratics is this. All real numbers. Okay, so it's all real numbers. By real numbers, we mean numbers that are on the number line. Now, you might be wondering, well, what kind of number is not on the number line? That would be an imaginary or complex number, and that is a separate lesson, usually introduced about the same time that you're talking about quadratics. But so you may or may not have heard about them already. Just if you haven't, you will soon. Okay, so the domain for quadratics is all real numbers, anything in between that negative infinity and positive infinity. There's a symbol and a notation you can use for this. So the symbol is this. It looks like a funky R. So it looks like the letter R, and then you just put this extra bar on the back of it. And that is the official symbol for all real numbers. So you could write it out in words, or you can use that symbol. That symbol is our shorthand for, hey, everything on the number line. Now, there's also another notation, and I have queued up a video introducing this notation. So I don't want to get too into the nuts and bolts of this. You can go look at that video. Right now, my computer is taking hours to process videos, so not sure what's going on with that. But here's the notation. You actually use the parenthesis notation that we would for ordered pairs, but this is something different. It's called interval notation. And what you do is you put in negative infinity on the left and positive infinity on the right. And what that notation means is everything from negative infinity to positive infinity. In other words, all real numbers, like everything. So that would be your way of writing the domain. So the domain for every single quadratic everywhere is all real numbers. I tell students this all the time. If you are taking a test on quadratics, if you recognize it's a quadratic and the question is, what is the domain? The answer is all real numbers. Maybe half of my students will absorb that and actually remember it. I don't know what happens with the others, but you're not part of the others, okay? So we have all real numbers, and that's why you don't want to just focus on quadratics, because this is not the case for every function. Okay, not every function has a domain of all real numbers, but every quadratic does. All right, so now let's take a look at range. Okay, so we're going to define range. So we got domain, it's all of those things that you can put in to your function, and for a quadratic, it's all real numbers. For range is the set of all numbers that you can get for the output. So what is possible for you to get? Now, sometimes that is also all real numbers. If we were dealing with a linear function, then unless it's a horizontal line, which is not super common, that is also typically all real numbers. Now, graphically, this is the set of all numbers y can be. So if you're looking at the graph of something, each point on that graph has an x and a y coordinate, and we're looking for what are all the things that y can be. So for example, we're looking at this piece, okay? That is our output. And we're asking ourselves, what could we get here? Can we get a 0? Is there something we could plug in for x that when we evaluate that, we would get a 0? In other words, is there a number that maps to a 0? Is there a number that maps to a 1 or a -1 or positive 100 or whatever? So to get that, I recommend most students look at the graph. Okay, and what we want to notice as we look at the graph for this is that we have all kinds of points on our parabola. Okay, look at all those points. They're putting lots and lots of points on that parabola, but there is a smallest y value. Okay, and that's right here at the -4. Okay, it's right there at the -4. It doesn't get any lower than that. So is there an x value that will give us a 0? Absolutely. In fact, it looks like there's 2 of them. There's 2 different x values that would give us that y value of 0. There's one x value that gives us that -4, but if I come down here to like -5, or I don't know where we are there, but yeah, that looks like it'd be a -5. There's no parabola down there. Okay, there's no x value that I can plug in that the y value is going to come out to be a -5, because I can see on the graph doesn't go as low as -5. And so our range is actually everything above that. Okay, it is everything above that. And so we can express that by saying y is greater than or equal to -4. Okay, that is our range, which I have a feeling when I click the next thing, it's going to pop up there, but yeah, there you go. So that would be our range. So our set of numbers that we could get out, well, I can get out -4 if I plug in a -2. Okay, so if I put a -2 in there, I put in a -2 there. In other words, if I plug in a -2, I would get the -4 out. That would be part of my range. And I can get anything bigger than a -4 out, but I can't get anything lower. So range is greater than or equal to -4. So there we go. So the smallest value for any of the points, y value for any of the points is -4. Therefore, the range is y is greater than or equal to -4. Now, generally speaking, Find the vertex using the formula or graph the function to see where the vertex is. The formula is this. You would find the x coordinate using the opposite of b over 2a, and then you would take whatever that number is, okay, whatever that number is. So maybe you get like a 1, okay, you get opposite of b over 2a is 1, then you would plug in f of 1. Okay, and then we give you the y coordinate. Or if you are allowed to and have access to, you can graph it and just click on it. Desmos is fantastic for that. So just graph the parabola and go find the vertex, and the vertex will tell you where that highest or lowest point is. And then the range will either be y is less than or equal to the maximum, or y is greater than or equal to the minimum. Now, I don't really want you to memorize that. I want you to memorize the definition, or really internalize that definition and then what it means, because if you're just trying to memorize that, it's going to tangle you with a lot of vocab that won't work when your function is not a parabola. But here's what we mean by that. If the parabola looks like this and you've got a maximum, okay, meaning a highest point, then your y value would be the maximum and anything below it. Therefore, the less than or equal to, because you're going below. If your parabola looks like this, okay, then you have a minimum or lowest value, okay? There's a smallest value that y could be, and anything above that, which would be your greater than or equal to, and you would be looking again at that y value because we're looking at the outputs. But again, the concept is more important than trying to memorize this. Okay, just look at what your y values are, and that will serve you better when you start to look at exponential functions or radical functions or other kinds of functions that don't necessarily have mins and maxes. Okay. So again, don't try to memorize the pattern. Instead, focus on the definition and using the graph. Like, what do we mean when we're talking about range? So we're going to do an example here to state the domain and range for that function there. And again, you could use that formula. Okay, so you could do the opposite of b over 2a. So my b value is 6, my a value is -1. So it would be the opposite of 6 over 2 times -1. So I'll have -6 divided by -2, which is +3. And then you would plug in that 3. And that would tell you what your y value is. Okay, so this looks like this would be -9 plus 18 minus 7, which is +9 minus 7. And so it looks like we would have 2. So when x is 3, y is 2. And that's what that looks like. I don't go over that too much. I have like a little short, like 2.5-minute video that goes through that process. But let's go take a look at the graph. Oh, look, guys, look at this. It's amazing. The vertex is 3, 2. So you can actually do that by graphing it, click on it, find the vertex, or this is the algebraic process that you would go through if you did not have access to a graphing calculator, okay? So you got a little bonus. Who doesn't want some bonus math? All right. Now, for your domain, remember, if you are dealing with a quadratic, the domain is all real numbers. So you can either use the symbol or you can use that notation, follow your teacher's directions on how your teacher wants you to write that. So the domain is all real numbers. We can plug in anything we want for x there. You can also think of it this way. This parabola is going to continue to move leftward and rightward. Okay, now I realize it's moving down, but it's moving left and down, and it's moving right and down, which means eventually you're going to get to the -6. Now it's going to be like way, way, way further off the screen than this, but eventually it will get there. If you want to find out when it gets there, go plug in the -6. It'll tell you when you get there. Now for the range, the graph can come in really handy. The range is all of those possible y values. Well, I can see I have y values that go down here into the negatives, and they go up as high as 2. And so my range would be y is less than or equal to 2. How do I know it's equal to 2? Well, like right there. When x is 3, y is equal to 2. So we got the 2 there. And it can be anything less than 2. How do I know that? Because the graph is heading downward, which would be my less than. All right, that's it for this lesson. Please like and subscribe for more math help. Drop a comment or question below, and please check out the practice set for this lesson. Domain and range can cause issues, and it's better to get it with quadratics before you move on and start to like swim in other functions. So check out that practice set, and I hope to see you in a future video.